some of this before. For example, have you substituted and solved for a variable before? Yeah. Yes, you've all substituted and solved for a variable before. You're actually going to do a lot of that, but we need to understand what it means for something to be an inverse. So for example, let's look at these two functions. There's the function g and there's the function f, and they're being defined in this set notation. So when you plug -2 into the function, what do you get out on g when you plug in -2? You get out 2. When you plug in -1, you get out 1. 0, you get 0. 1, you get 3. And 2, you get what? 5. Here's a function f. When you plug in 2, what do you get out? -2. So what do you see a sort of relation between these two? They're kind of opposite sorts. They go in reverse. F undoes g. If g takes you from A to B, F takes you from B back to A. So we're going to study later the two types of functions that are called exponential and then logarithmic functions. They are inverses of one another, but we have to understand what an inverse is first. How to tell if something isn't in one-to-one functions. What can you tell me? What do you think the difference is between a one-to-one function and a function that isn't one-to-one? What's the one structural difference there between those two functions? One function, the not one-to-one one is doing. Yeah, there's this thing here. It's not really, you don't say two domains. There's two things in the domain. We've talked about this a little bit. We talked about what makes a function. Do you remember that? Let's just go back to that for example. This is a function, right? A. But what about this? Why isn't that a function? What type of line is the y-axis?
Straight.
All lines are straight.
No.
It's vertical.
It's vertical. There's something called the vertical line test. Does this pass the vertical line test? Because there is a vertical line. It doesn't have to be the y-axis. There is a vertical line that passes through this relation more than once. This is not a function, right? What is this, though? By what you can see right here. Oh, this is a function because every vertical line you can possibly draw only crosses it how many times? If at all, right? Going to here, if you took this, this meant, let's say that this was an x value right here. Let's say that was x equals 6. Let's say that was 3 for y, and this was 7 for y. When you plugged in 6, what could you get out? How many different y values? Many. How many when you plug in 6? 3. When you plug in 6, you get out 3 or 5 or 7. You couldn't go from one x value to multiple y values for it to be a function, right? We get to make it even better now, though. What does this go? This is two different x values going to the same y value. That's actually fine because, for example, the function x squared. What's 2 squared? What's -2 squared? 4. 2 squared is 4. -2 squared is 4. A function can go like this, and you can have the same y values, right? Can you repeat y values with a function? Yes, you can. But look at this. What does this say for one-to-one? It says, if you have two x values, can they go to one y value? No. What happens if you had something that looked like this? Let's say 2 also went to 6. That wouldn't be a function because 2 would be going to 6 and 7. Can one x value go to more than one y value? No, or it's not a function. But if you have this right here is a function, but what is it not? So what this means visually, here are all functions. There's two types of functions. What are the two types going to be? One-to-one and what? Not one-to-one. Not one-to-one. So this right here is not one-to-one because there's more than one x value that points to the same y value. There's x value. So it's one-to-one. One x goes to one y, and one y goes to one x. These are great functions. I'll give you a visual representation. This right here is a one-to-one function. This right here is not a one-to-one function. Can you tell me the difference between those two? This one is one-to-one on the left. This one is not.
Because they don't go over the x-axis.
There's no axes drawn there.
Can it be kind of like if you draw a horizontal?
Yes, there it is. Is that what you're going to say? Take a look. This is a function because it passes the vertical line test, right? Is this also a function?
Yes.
Yeah. They pass the vertical line test. But what can you do for 1 to 1? It also has to pass the, oh look, this passes the horizontal line test, which is the exact same thing as vertical, except it's horizontal. But look at this. If you draw this line, how many times does that cross? More than once. So is the one on the right 1 to 1? No. They're both functions because they pass the vertical line test, but the one on the right is not 1 to 1 because it doesn't pass the horizontal line test. Yes, Calvin? Because what are you going to think of every time you see f to the negative 1? It's not, you think of that, but it's not that. But it's really important. It's not 1 over. I'm going to show you how to find the inverse. I'm going to show you how to find it. It is not 1 over. Sometimes does the inverse come out to be 1 over the function? Yes, but does it always come out to be that way? No. You need always. So look, if xy is in one set, yx is in the other. Because when you plug x into the function, what do you get out? Y. But when you plug in y into the inverse, what do you get out? X. It does it in reverse. It undoes it. It undoes the function. And this is really important because when we talk about exponential functions, there are some exponential functions we can't work with. So instead we work with the inverse and work our way backwards. It's kind of cool. I like it. So let's actually do something. You might want to.
X. I guess
there's more than one x that points to the
same
y. Right. So look what you have here. 1 going to 2, right? So you have both of these 2's. 2 goes to this, and 2 goes to 2. You can't duplicate at all.
You have it with a 1.
And also you have it with the 1. 1 goes back to 0, and 1 goes back to this. So what test would this not pass?
Horizontal.
Not pass horizontal. Right. Correct. What about G? Yeah, there's no repetition, right? There's no, by far, just by those 4 points. Could there theoretically be other points? Yeah, but if the function is just those 4 points, just those 4, this is 1 to 1. What about this one? This table right here, is this 1 to 1? Take a look. Yeah, they're highlighted. It was kind of, I was trying to figure out, I don't know how to quickly take the color out of an image.
Why can't you have 13 go to 13?
Because in 2000 it goes to 13, and in 2006 it goes to 13. There's those are yeah, I'm sorry. This is one part of the table, and this is another continuation of the table. It's not different ones. It's the same table. No.
13, like 20, and then
That's fine. If these were separate, they each would be 1 to 1. But as a whole, what's going on here? It looks like it's going up, and then it goes down, it goes up, it goes down. Like, it will not pass the horizontal line test because 2000 exports 13, and 2006 exports 13. We are generally only going to be working with 1-to-1 functions when we do any of the actual inversion. Weird things happen when you invert non-1-to-1 functions. Weird things happen. So we're only reading it 1-to-1. That was good. F of x, or don't have to say f of x, y equals what? What slope? Give me a slope.
3x plus 10.
Sure. This is a line. Is all lines except horizontal lines are 1-to-1. So we're checking, is this 1-to-1? Yes. Does it pass the horizontal line test? Yes, it does. So the first step, and I'll plug these in here. Here are the steps you need to follow to find the inverse. We're going to find the inverse. Here they are. The first step is interchange x and y. So if we do step 1, what does it become, Hannah, if we interchange x and y? Nope.
Okay.
Nope. Interchange them.
Oh, you'd have 3x.
X equals
3y.
correct. That means interchange. Every x replaced with y and every y replaced with x. That was step 1. What does it say to do next? Solve for y. So if we solve for y, someone give me the first one step I should do to solve for y. What should I do first? Subtract 10. X minus 10 is equal to 3y. Now what do I do? Yeah, so I end up with x minus 10 over is equal to y. And we like having it switched around, so y is equal to what? And you might write it as this instead. 1/3 x minus 10 over 3. So our inverse, I like writing it like this. 1/3 x minus 10 over 3, just to be super clear. We solved for it, and now what does it say to do? So if this was our original f of x right here, what's our inverse going to be? F inverse of x is equal to what? 1/3 x minus 10 over 3. Let's just check this to see if it works. It's got to work with all points, but let's just check 1. What x value do you want to test with this one? Just pick any x value. X equals 2. What is f of 2 going to be? 3 times 2 plus what? 10, so that's going to be what? So when we plugged in 2, what did we get out? 16. So what should we plug into the inverse? So let's go to the inverse here. F inverse of 16 is going to be 1/3 of 16 minus 10 over 3. What is that? 16 over 3 minus, which is 6 over 3, which is what? Ah, did it check? Just testing 1 doesn't prove that it is the inverse. But what happens if we plugged in 2, got out 16, but then plugged in 16 and got out 7? It proved that it's wrong. Exactly. You only need, listen, that was perfect. If we plugged in 2 and we got 16, but then we plugged in 16 into the inverse and got out like 7, exactly, it means it's not an inverse. It means we did the inverse wrong. So you only need one point to prove it's not an inverse, but does this prove it necessarily is the inverse? No. As long as you didn't make a mistake, you're totally fine.
How do you prove that it is the inverse?
You just guarantee you did your math right. See all this work we did in blue? Yeah. You guarantee it by not making a mistake there. And there's other ways, but there's no other method right now. In later math classes, and we might get to it, I can show you another test you can do. Okay? So I'd like you to do this. That's a very good question. Like, what's a better test other than did we do it right? You want to know if you did it right. Like, you can't define a word with the word itself. You can't prove something is correct by using the work you did to get the, you understand? It's like you have to have an independent test. There is. We're not going to do it right now. Let's say I gave you this here. Y is equal to 3/7 x minus 4. Find me the inverse of that function right there. So if this is f of x right here, if that's f of x, find me the inverse. Okay, what's the question? You know that dividing by a fraction is the same thing as multiplying by the reciprocal?
For the substituting it to see if you did that right.
Oh, like picking a point, you mean?
Yeah.
Oh,
For
x, you start here. So you start with, like, you pick an x value of 2 and you see what y comes out to be.
So I would do like 2 plus 4 divided by 3. But that would be
you would plug in, like, literally, pick any value. Like, pick 2, plug 2 in right here. 2 times 3 over 7 minus 4. And then you get a y value. And then you take that y value and where you plug it in. For x right here. If you wanted to check this. Let's check it. You want to check it?
Yeah.
Let's check it, sure. I didn't ask you to check it. Hold on. I didn't ask you to check it, but let's do that. That's totally a good question. Again, just 1 point just makes you feel better, right? So let's pick, let's pick 7. Is it okay if I pick 7? So if I plug 7 into this, plug 7 in right there. What's 3/7 times 7?
3.
What's 3 minus 4? But now we go to the inverse. Here's our inverse, right? What do we plug in for x? Not 7, we plug in. You take -1 and you plug it in here. 7 over 3 times -1 plus 28 over 3. What's that going to be? -7 over 3 plus 28 over 3. What's that? 21 over 3, which is what? Ah, did it work? For that 1 point, we verified. It makes you feel a little better, right? Usually, I'll put it this way. Usually, you don't get false positives. So if you checked it both ways, if 7 goes to -1 and -1 goes to 7, that's a really good sign that you did it right. Because if you did something wrong, it's probably going to mess up all of the points. Do you understand what I mean? Like, you're probably going to make some like division error and the whole thing will get shifted over here. So when it does the inverse, it's all wrong. This is a good sign. I didn't say check 1 point on this one, but it's a great thing to do to kind of give you more confidence. What is that? It's not a line. What is that? Parabola, okay? So if you were to graph this function, x squared plus 2, it looks like this, right? It crosses at 2. That's your parabola, right? So it's like the curve is pretty bad on that one, huh? Is that a little better? That's a little better, okay? Now, if you wanted to graph the inverse, I haven't shown you how to do the inverse of this thing. But let's say you wanted to graph it. You can always graph points, right? And just switch the x and y values. So what's one value? When x is 0, what's y? 2. Let's do when x is 1. When you plug in 1 into this, what do you get? You get 3. What happens when you plug in -1? What do you get? Well, there's 1, 3, and you get what? 3. Yeah, you do. So so this is the function. If I wanted the inverse, what's the inverse going to look like? What's the only thing you have to do to get the inverse? Just switch them. 2, 0, 3, 1, and 3 what? You just flip them, right? So we take these points. I'll do it in, let's say, a different color here. Let's say I do it in green here. If I do it in green, Where do those points live? There's 2, 0, right? There's 3, 1, and there's 3 also what? You can't see it? Sorry. How about this? I'll do it in gray. So there's this point right there, which is 2, 0. There's this point right here, which we said was what? 3, 1. And what's this point? 3, negative 1, right? If we connect these, what does this look like? So this is the function and this is the inverse, right? But what's the problem? So you would describe it as a sideways parabola, correct? Which test? The vertical line test, right. So this is the important thing. If a function doesn't pass the horizontal line test, its inverse won't pass the vertical line test and therefore won't be a function. We want our functions and their inverses to be functions. If you start with a function that isn't one-to-one and you invert it, what do you get? Not a function. This was a function, but it's not what? One-to-one. So when you invert it, what do you get? Not a function. We want them to both be functions. Look what it looks like mathematically. If we did it, y equals x squared plus 2. If we wanted to find the inverse, what's the first step, Rourke? X equals y squared plus what? So x minus 2 is equal to? How do you get rid of a square? What do you have to put in if you take a square root? Yes. So what do you end up with? Y is equal to plus or minus the square root of? This arc right here, I'll tell you right now, the top part, can you see that highlighting? That's equal to y equals the square root of x minus 2. And what's this bottom part equal to right here? Exactly. The bottom one is y equals negative. If you ever have to have a plus or minus in your answer, it's not going to be a function.
I don't understand why it's not, why it's turned instead of just upside down.
I'll tell you why. Because we'll do a bunch of these.
Yeah.
So could I give you a bunch of points and you just switch the x and y and you move it? It is. So what I want to show you is the reason is this is what you end up getting. This is the really, really important thing to realize about what we're doing geometrically. So algebraically, are you okay with substitution and solving? Yeah. Geometrically, this is what it looks like. Let me get this a little smaller. When I go up here, we did this right here. Did the shape of this parabola change? Did the overall shape change? It was like we took this, if we cut this out, could we put it exactly right there? We could. It only changes its perspective, right? Can you tell me there's a line that we could draw on this somewhere where you can reflect it and get the same thing? Anybody want to guess what the reflection is? Y equals what? What do you think? No. What do you think is line? Yes. Take a look at this. If I put this in right here, you see that? What happens if I folded the board right here? It would go exactly over it. It's a reflection over the line y equals x. It's a reflection over the line. So look at this.
That's like geometry.
Yeah, that is geometry. So here, what this means, the reason is, if you switch A and B, we can prove it algebraically, but if you switch A and B, it is the reflection over this line. So for example, if I were to have a bunch of points, so let's say the function did this, went up like this, what would it do? It would go like this, because you would need to do what with each of these points? I can't draw a straight line. So let's say, can you see those points I did? You see these? This point right here would go all the way to there. It's a reflection over the line. This distance is the same as this distance. And what's the angle right here? It's a 90-degree angle, right? So you can either do it geometrically. So if this was the function right here, what's the inverse look like? It looks like that, because this point gets mapped here. So either you make a table and you switch the values, or you reflect it. One really fun way to do it is you literally take your piece of paper and you take some pencil lead, right? And what do? You graph your function, right?
Yeah.
And you scrape off a lot of pencil lead, and then you literally, it's really fun to do, we can do it sometime, not this class, we do it all the time. You fold the paper over y equals x, right? And then you go, you tap it down, and then when you unfold it, what do you see? Remember? Yeah, you can make it's a symmetry. You can make it so if I drew the function, but then I did this, it's going to take all of these points. So if I literally put a bunch of pencil lead here, here, and here, and then bent the board and tapped it down, what would it trace out? The inverse, exactly. What's the inverse of the inverse? The function itself. If I take a value in the function and go to p, the inverse does what? Brings it back. So what's the opposite of the inverse? The function itself. So if you invert something twice, where do you end up? Where you started, exactly. Where you started. How many points do you have to have wrong for it to be not an inverse? Just one. So if I took this right here, we have like 90 more seconds, so bear with me. If I took this right here, and let's say you graphed it and you had this one, you're like, yay, that's what it's supposed to look like, right? But then your inverse was like this. It's obviously not the right thing, right? So you can quickly get a visual idea. What are the only points they can share? The inverse of the function. Where they intersect what? Y equals x, exactly.